Hey guys, welcome back. I want to go ahead and talk about how to use the binomial theorem, binomial expansion. And if you guys already know, we take it from Pascal's triangle. And if you've never seen it before, it's just a triangle. It starts with three ones, okay? And basically what you're doing is it's a way to expand binomials in a very, very quick manner. And it's basically nice because there's a pattern. And if you notice, all you do is you add the middle. Okay, 1 plus 1 is 2. And then the corners or the ends, it's always 1. So the next row down is 1 plus 2 is 3. 2 plus 1 is 3. And then the ends are 1 again. And then 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. And then, of course, again, the ends are 1. So I'm going to go ahead and do a couple of examples just to let you know what it looks like. Okay, so the first one we have is 2x plus 3y cubed. And so I'm going to have this pattern here. Okay, so I'm just going to go ahead and write it out. And I'll just do a cubed plus 3. And what you notice, the cubic is going to become a square. And then we're going to start adding the second term, okay, the b's. The b's are going to increase. Plus another 3. Instead of a squared, it's going to be a. Now the b gets higher, b squared. Plus, now there's no a, and then we have finally a b cubed. Okay, and so if you can notice that as the a's are descending, the b's are ascending, they're getting bigger. So this is kind of like my pattern I'm gonna use. So this is my a and this is my b. So right here is a and that's your b. So whatever is inside here, I'm gonna put it here. Okay, so let's go ahead and I'm just gonna go ahead and use parentheses. Plus 3 parentheses, I'll do that squared, another parentheses here, plus, now there's a 3 parentheses, b to the second power, and it's gonna go over, but it's okay. So just you guys can just see what it looks like. So instead of a, I'm gonna put 2x right there. Okay, now right here I'm gonna have again 2x. Now what's my b? Well, it's 3y. And then over here, what's my a? Well, that's 2x. What's my b? Well, that's 3y. And then here, what's my b? 3y. And then you're just going to go ahead and simplify it and work it out. So 2x cubed, you should get 8x cubed. Right here, this is 4x squared, or 4 times 3 is 12, times 3 is 36. 36x squared y. Now here, 3 squared is 9, 9 times 2, 18, or 9 times 6 is 54. 54x y squared. And the last one, 3 cubed, is 27, and y to the third. So this is what it turns out to be. That's how you expand it, and that's its simplified version. Okay, I want to go ahead and do one more, just make sure you understand it. But this time we're going to go ahead and use the minus, okay? And it's much the same process, all right? So let me go ahead and do it down here just because I ran out of room. And we're going to go ahead and use this guy here with the 4, okay? So this guy here we're going to have is, let's go ahead and put it here. Hopefully I don't run out of room. It's going to be a to the 4th plus 4a cubed, but then the b starts coming out, plus 6a squared. Now b starts increasing squared, and you notice they add up to 4. Plus, now you have another 4a to the first, and then b cubed, and then lastly b to the 4th power. And it might get a little messy, but I'll go ahead and expand it, okay? Alright, so a, instead of a, I'm going to have 3x. Here's my a, here's my b. So this guy here becomes 3x to the 4th power plus 4. And that'll be 3x to the 3rd power. Now what about the b? Now be careful, now that's a negative in front of that too, so you have to use that minus 2y. Okay, b plus 6, hope I have room. Alright, and that's going to be 3x squared. And you can see it kind of gets a little bit messy sometimes, just kind of tedious, but once you get the hang of it, it's no big deal. And that becomes squared. Let me switch that. Alright, and I think I'm going to have to continue down here. Okay, so I left off with the 6, and now I have 4. 4 parentheses b to the third power plus, and then something to the fourth power. So right here with the 4, what's my a? Well, that's 3x. What's my b? That's a negative 2y. And then lastly, what's my b? That's a negative 2y. Okay, that's what it expands into. So that's to the fourth, to the third, to the second. Then this guy here is here, and b to the fourth is right here. All right. So it does get kind of messy, but let's go ahead and see if we can simplify this out. 3 to the fourth power, well, 3 cubed is 27, so I believe that is 81 x to the fourth power. Okay, here we have, sometimes they get big, 27 times 4 and times a negative 2. So 27 times 4 times 2, 27 times 8. So that's going to give you 216, but it's going to be a negative 216, okay, because of that y right here. And remember, and getting ahead of myself here, 216x cubed y, and now we have here, that's going to be 3 squared is 9, 9 times 6 is 54, and then 54 times another positive 2, okay, is 108, and that's going to be a positive 108, and that's going to be x squared, y squared, okay, right here. Then we go to the next one. Negative 2 cubed is negative 8. Negative 8 times 12 is negative 96. And that's x, y cubed. And then lastly, plus negative 2 to the fourth power is 16. 16 y to the fourth power. So you can see sometimes it gets kind of messy, but once you understand the gist of it, use Pascal's triangle. It's pretty simple. But just remember, notice that when it's an odd exponent, okay, odd, it stays negative. Okay, if you notice here, negative 2 cubed, that gives me the odd. And what you're going to notice is the alternating pattern is positive, negative, positive, negative, positive. And that's what happens when you have the binomial with a minus. Alright guys, hopefully that helps. I'll see you guys next time.